So welcome to this, the latest edition of the Data Standard Audio Experience. I'm really excited today to welcome Mekki El Boushi. Mekki, welcome.
Thank you very much. Glad to be here.
My name is Matthew Rawl. Again, the goal of the Data Standard is really, we believe that data, and in particular AI and ML, have the power to solve a lot of the world's challenges that are coming today. Yes. And so we're really excited to speak with leaders, executives, engineers, data scientists that are kind of at the cutting edge. And Mekki certainly fits into many of those different categories. So without further ado, let's just go ahead and get started. Mekki, welcome to the show. I think the first thing we always like to do for our listeners is just kind of give a short background on kind of your career and how you've gotten to kind of where you are as today Chief Technology Officer at Planet Bingo.
Yeah, sure. Thank you for having me. I'm a physicist by trade. More specifically, I specialize in astrophysics, studying things like MHD, magnetohydrodynamics, which is the wave-like properties of magnetic fields. Ironically enough, when I got to NASA's Jet Propulsion Laboratory, I wound up studying and doing research in gravitational astrophysics, which is how the gravitational curvature of space and time controls the motion of inertial objects. More specifically, astrodynamics, or what was also known as celestial mechanics, which is the practical concerns around the motion of objects and or spacecrafts. So all of these fancy words is basically how can we successfully fly a spacecraft through space given all the different variables at play like gravity, magnetic fields, electromagnetic fields, etc. Traditionally, they've always been two forms of research in science, either experimental or theoretical. For a brief period in the 80s and 90s, a third form emerged, which was computational. That has subsequently been rolled back under theoretically. Anyway, it was under this computational physics that I first experimented with AI. So that gives you an initial background on me.
Okay, I mean, holy smokes, there's a lot there to unpack. but I mean, talk a little bit about, so I mean, this is awesome because right from the beginning of your career, you already were exposed, at least on the theoretical side, to kind of the power of AI, right?
Yes.
So kind of, I'd love to just hear from you the evolution of this whole idea, because today, you know, everyone talks about AI and machine learning and how kind of that they're going to transform society as we know it. But I mean, you're talking at the beginning of your career, you're already kind of, you were in it, you were seeing it, you were seeing it kind of grow. Can you just talk a little about kind of how that perspective has changed over the last couple of decades?
Definitely. So as you know, the whole concept of AI has been around for a while. I think we are into the third iteration. I was initially part of the second iteration, and I am now part of the third iteration. During this second iteration, we still held on to the utopian ideals that AI meant a computer that emulates human thinking and not so much behavior. Unfortunately, this was back when we had the limitations of the computer, both in computational power, memory, and storage space. For all intents and purposes, computer technology was still in its infancy. So exacerbating things even more was we were using developmental languages that were very bloated, inefficient, and resource expensive, like Lisp and Prolog. So the limitations of hardware technology, development platforms, and storage made the second foray into AI a brief and limited one. The death of the second iteration came when we realized that we could use supercomputers and parallel processing to achieve what technological limitations we were faced with at the time. Mm-hmm. The problem with AI was that we still had not found a way to quantify it and make it useful beyond the academic and national research labs. Anyway, my first practical use of AI was at JPL and Jet Propulsion Laboratories and the Mars Pathfinder mission to Mars and the Sojourner rover, which is ironic that we're talking about that because literally right now, the Mars Perseverance rover is the latest generation that is actually on Mars right now.
Yep.
We had programmed the rover to be able to recognize some simple things like types of dirt, fields, and particles. And we spent a lot of time building the application, which unfortunately, due to politics, was never turned on. Ultimately, we had hoped to start using AI for a whole myriad of things on spacecrafts. And at the time, there were, for all intents and purposes, the Russians and us in space. The European Space Agency was still in its infancy. So the Russians used what we call a burn-in instructions. They basically sent up their remote sensing objects and they basically said, okay, go out, 100 feet, turn right, turn on your high gain, go another 20 feet, do a field and particles. We sent ours up empty without any information. And what we did was we basically said, based upon the information we got on it, on our road sensing, we then gave it instructions. So if we saw something and said, hey, that's interesting, let's spend more time doing something. So we thought, how can we use AI to make it more practical? Because again, it was still very theoretical. So for instance, let's take the example of Mars. So you're on Mars and a signal takes, at the speed of light, about 4 minutes to get to us when Mars is at its closest point to Earth. And it takes about 14 minutes to get to Earth when Mars is at its furthest point. So let's take the example, let's say it's midway and it's about 10 minutes and you see something. And so you take a picture of that. It then takes 10 minutes to get back to us. We then spend a couple of hours trying to decide what we're going to do next and then send the signal back. So let's say we were very efficient, 2 hours all told. During that 2 hour period, it would have been nice to use AI to basically do some simple things. It's not wasted time. You're actually going through and the rover's doing something, it sees something, and it's continuing the analysis while we're giving it more specific instructions. A more salient example would be if we use, say, for instance, Jupiter. Okay, so now you have a spacecraft rotating around Jupiter, and a signal at the speed of light takes about 35 minutes for it to get from Jupiter to Earth when Jupiter is at its closest point. It's about 52 minutes when it's at its furthest point. So let's say you have the spacecraft now going around and it's supposed to go do a flyby of Io. But the last time we went by Io, there was nothing happening. But this time that it's going by Io, the actual volcano is going off. But it would take us 45 minutes to figure out all that information, get it back to us, and then it's too late. It's already gone by. So then we would have to actually try to redirect the spacecraft to go back again. Whereas what we could do now is actually say, hey, the AI is going to take over. It notices that suddenly there's a volcano that's erupting, and it can then do, move the scan platform, do the field and particle, turn on the videos, all the simple things that are instructions that it could give it. So those are the practical things that we were talking about doing. From a philosophical perspective, I want to back up and say, I would argue that AI has never existed. And that was what we were doing back then. What we were doing back then was nothing more than machine learning in its infancy. Regardless, we now have the technology to implement and use ML. I think it's going to revolutionize fields like medical fields, weather prediction, IoT. So types of ML that are going to be very prevalent are in human speech, automated vehicles, as we're seeing, IoT, clean energy. Ironically enough, I have a friend who actually owns a company that uses AI to detect birds, namely eagles, that fly too close to those wind turbines and then shuts them down. It's going to revolutionize medicine. And then let's take, for instance, gaming. Which is broken down into multiple disciplines, which is the one I'm in now. So that's why I'm really excited, because I saw the second iteration and now I'm a part of the third iteration, which is the actual practical use of ML. So gaming and let's say sports betting. ML is going to be huge in developing customized reports, game previews, reviews for each user. It's going to drive predictability by taking patterns in the data about the people and how they're either interacting or using the system. See, another thing is a big truth about gambling games is that 90% of the patrons are trying to cheat the system in some way or fashion. The use of ML is playing a big part in combating this and trying to stay ahead of the millions of unique, interesting ways people try to game the system. One of the ways this is done is by using ML to generate odds. Of course, when all else fails, you have to introduce the traditional methods. On the brick and mortar end, like casino end of things, we're using ML to improve safety and quality. Things like preventative maintenance. We have so many interdependent parts and variables on a casino floor: Wi-Fi, networks, power, temperature, etc. So it's extremely costly and difficult to deal with down pieces of hardware, or what we call EGMs. They're electronic gaming machines. So using ML to predict failures is huge. This is great for risk planning and risk mitigation. And then, of course, obviously, the ones that you know about are the first-person shooters or the MMOs, which are massively multiplayer online games. This is all the ways for creating the environments to the gameplay. The game engines learn and simulate and adapt players.
I mean, there's all kinds of use cases that you just kind of pulled out there. You talked about a little bit in the second iteration of AI that we didn't necessarily have enough compute power, right? And
Yes.
then you mentioned that in the third iteration that's not really an issue anymore with parallel supercomputers and parallel processing. What are some of the complications that you see in making some of these use cases? I understand some of them are already happening, but in really making them ubiquitous so that they're everywhere and that the common person is taking advantage of these things. What are some of the hurdles that you see right now?
The unification of the actual platforms. One of the things that I see that is kind of disturbing to me is, on the one hand, there are, let's say, the architectural platforms, the actual programming languages that have come a long way and have really, I mean, they're very, very interesting to me. The whole thing of data sets, using large databases of, the IDEs, all those kind of things, that these languages are now very, very, very things. But one of the concerns I have on the other end of things is these languages that Google is now trying to promulgate, which is Go. And these are things that are basically made for a psychologist to come in and basically say, the degree in psychology or in English, to program. And that's not what we need. What we need is basically some of the languages on the other end of the spectrum, which are now starting to go along. And one of the problems that we had was that we had to really pay attention to the fact that we couldn't do platform agnostic. And that's one of the things that we're going to have is a platform agnostic, platform, so that you can go across, let's say, Android or Linux, go across iOS, go across Mac, Microsoft, and those kind of things, so that you can program to basically any platform and optimize from there. Now, that's for the pushing of ML as we know it. If we're talking about pushing for basically AI, that's a different conversation, because we don't have the ability to get there right now. So if we look at quantum computers, which is now the thing, a quantum computer, even at its best, can do calculations out to the 10 to the 18. That's probably, the ones they can have now are 10 to the 12 or something like that. But if we ever do realize it, but you can just imagine that the flakes that come off of your skin, all right, have more memory than the 10 to the 18. You know what I mean? So if you're trying to emulate a human person and a human behavior, so it goes beyond just a robot. And what's happened is the scientists in first iteration, they had this utopian ideal that they're going to build this thing that emulates a human person. That's the ultimate objective. That's not very realistic in the paradigm that we're in. And it's not going to be until there's a major paradigm shift, because we need to get computing power that has the ability to say 1 mole. 1 mole is it's the mass of 1 mole of chemical compounds in a gram. The average mass of 1 molecule is 10 to the 23. It's 6.02 times 10 to the 23. So if you can see the magnitude of order that a human being has on something like that. So I think we need to get away from the concept of we're going to do AI, we're going to do ML. That's what we're going to be doing. And until there's a major paradigm shift, because not only in computing power, then you have to have a paradigm shift in storage, the amount of storage that you have. And then the third thing is that, how do you access that storage? Okay, great. You have a storage now. Let's say it's a crystalline-based storage. How do you access that storage instantaneously? So will there be a paradigm shift to that? Yes, there will. Will it happen in my lifetime? Probably not in mine. Technology follows evolution. See, evolution goes along, and every several hundred million years, nothing happens. And then in a 10 million year period, suddenly, a fish walks out of the water, grows legs, has a lung, and things like that. And that's what's going to happen in technology, the same thing. So we're going to go a long period of time and have something like that happen.
Let me go back to one of the obstacles that you mentioned, which is around having all these different platforms be able to talk to each other, right? It almost sounded like you were almost referencing like an enterprise service bus. And again, I know that's a very archaic kind of, that's legacy, but is that kind of what you're saying? I mean,
yes, it is. Absolutely. I mean, we're going to have some unified form of language or platform or architecture is what I'm basically saying. And that's going to be so that we can go across these different platforms, because you're never going to have one system. You're always going to have people with different, and that's that the platform's got to become irrelevant. All right.
Okay.
Because we're trying to push this out to the user, and the end user doesn't care. And they shouldn't be limited by, okay, I want to buy this product because only, it doesn't matter whether it's an IoT, you connecting that to your vehicle, or you now want to somehow get your medical records, or all that kind of stuff. So there does need to be an enterprise.
Okay. So another thing I'm really curious from you, just because you have so much experience here, is I'd love to hear your take on kind of what are the societal implications. On one hand, you hear kind of, are a bunch of people going to lose jobs with automation, and are we going to have like some sort of total rethink of the way that we, compensate people that can't find work? Or is there going to be an explosion of productivity that's going to lead to just a general, increase in the standard of living for everyone, in the United States? Like, how do you think about those problems, and what do you think, the administration, the leadership should be thinking about when they look at, and again, we'll just talk about machine learning, all the things that you talked about, the discoveries and the possibilities that are coming. How does society need to prepare for that?
Oh my God, this is a subject unto itself. Yes, and we have as scientists have had this discussion with us. Is it going to affect society? Absolutely, yes. Is it going to have a negative impact? Yes, and it's going to have a massive one. The reason being is, as a scientist, we are asked to do three things: faster, better, cheaper. That's what we're asked to do, and society asks us to do that, and we do it. A good example of that, and I'm just, it's not AI related, is like the garbage truck. When I was growing up, the garbage truck had 8 people working on it, 2 on the front, 2 in the middle, things. Now you basically have a garbage truck that's so efficient that it can basically do an entire neighborhood. All right. You can break it down into 3 different pieces. And that's because we're doing faster, better, cheaper. So that's what's going to happen out of this. It is going to definitely displace a huge part of our population. And it's going to require that. Will they stay up? No, they won't, because you're going to have to be more educated. A high school education is just not going to do it. Mm-hmm. And we can automate things to make it easier for high school people to do things. But in what we're actually saying is that we're also automating it to take you and not have you have a job. So that is a very, very good question. And are there going to be implications? Yes, there's going to be huge implications. Is there going to be a large swath of us that are going to be out of a job? Yes, we're doing that. As a CTO, I'm driving that. I'm trying to be faster, better, cheaper. And it's not only happening at the lower end. Look at the IDEs we have now. When I started programming, the simple thing is a mouse, that little mouse on your cursor. All right, that was hundreds of lines of code.
Yep.
You know what I mean? To draw just something on the screen was another hundreds of lines of code. And then you had to move that cursor and all those kind of events and callbacks and all that kind of stuff. Now you turn on the ID, that's literally inherent in any code you have. You have code that does its own documentation. The latest IDE, builds a built-in reporting, all these kind of things. So basically what it's doing, it's basically taking away people at the programming level. You no longer need as many programs. I don't need as many tech writers because it's building the documentation. You write the code, it builds the documentation, and then that's my documentation for my user guide. So all those kind of things. So it's not only happening at the lower end of, like, let's say, high school education, it's also happening for people that do have a degree, an advanced degree. So this is a larger conversation, and the implications to our society are going to be very, very huge. Do we do it from an administrative standpoint in the sense of give them, take care of? That's only a Band-Aid. We need to address the bigger thing is everybody's going to have to step up educationally. They just are. Otherwise, they're going to get left behind. Okay.
So there's 2 other questions we always like to ask. And one of them is, from your own role as a CTO and kind of what you're working on now, because we have a big community and a lot of different folks across the spectrum. Can you talk about kind of the 2 or 3 biggest initiatives that you're working on? And again, high level, not asking you to give any insider information, but kind of when you look out kind of the next 2 to 3 years, what do you see at Planet Bingo? What are the big challenges that you as a CTO are focused on?
Basically trying to build a platform that will scale and be robust enough for 10 to 15 years. That's the hard part. It
Okay.
really is. Because, you know, an R&D effort is expensive. And for you to sit there to go to the board of directors, or you get approval for something and say, okay, I'm going to build this initiative. And then in 5 years it's done. You can't go back and say, okay, I want to get the next initiative. So the ability to look down out 10 to 15 years and around the corner, that's one of the most key things that I think. So my biggest thing is, having done this multiple times, am I on the right platform? You don't know what is going to be on. 15 years ago, there was no such thing as a RESTful API. Now there
Yep.
is, and that has revolutionized the way we do things. So can you build in and future-proof as much as possible so that you've built this enterprise? Because what we do here is we build enterprise software. It isn't just a widget or a mobile app or something like that. It's end to end. It's got a middle tier, a lower level and a high end and a front end, all of those kind of things. And those things, and then the back end, which is a financial application to run the whole thing. So, can you build this thing to be relevant for at least 10 to 15 years? All right. Is it going to be modular enough so that when it does get old, I can bolt some things on and have it survive a couple more years while I do that initiative all over again, 15, 20 years from now, to go around that? That's the first thing. The second thing is, how do I exercise ML to really drive efficiency, to drive cost? Because one of the things as CTO is you got to worry about, the bottom line. What's going to be your revenue? What's going to be your EBITDA? What's going to be, all these kind of things that you have to worry about. You're not just a director where you're building the software, or if you're a CTO, and you have to be visionary in the sense of, as the company, how are we going to business marketing perspective, things like that. And then my third one is how can I make this easy on the end user? It's gotten to the point now where my mother uses technology. When it gets to the point where she uses technology, it's relevant. If it's still the point where she doesn't know how to use it or something like that, make it seamless. Like, it's not something that is very hard to use. It's literally like a pencil. And that's how you need to. Those are the three things that I work.
Okay. That's fascinating. Okay, so that's super interesting. The last question that we usually ask, and we have a lot of folks that listen that want to get into data science, they want to get into machine learning, they want to kind of get into the industry. So if you're speaking to, I don't know if you have children, but if you're speaking to your college graduate, or they're in university studying, what are some of the kind of the best practices? You want to go into a field like what you've done, your career. What do you tell them? What are your kind of keys to success?
One of the keys to success I have, which I'm kind of amazed that I'm kind of disappointed also in this generation, or it's not really the generation, it's the schooling that they get, is when I came up, I had to learn assembly. Those are the things that are kind of a requirement. You might not ever use it, but it's good to have. It's good to know. You need to know the fundamentals. You need to know the lower level languages, because it's easy to get these languages like Go that Google has out there, but those don't scale. Those aren't efficient. Those don't drive the things. So get to really, really understand that. Get a fundamental understanding of how it is to code. The logic behind it. So a great book that I always recommend is Compiler Languages by Aho and Seti. It's kind of like the Bible of things. Read it. Learn to things, because you're going to have to get down there, and your job is to push the paradigm, to push the boundaries. And the only way you're going to be able to do that is to have a good fundamental grounding in software development. And you don't have to know, .NET is relevant now. It won't be 15, 20 years from now. When I was coming up, it was, J2E. Nobody talks about that anymore. I remember OpenGL was the biggest thing, and now, that doesn't even exist anymore. So it doesn't matter what the language is, just know the algorithms, the logic behind it, and get fundamentally grounded in that, because that's going to serve you well as you're asked to, by your CTO, to push that paradigm. I'm not asking you to be on the edge. I'm asking you to be cutting edge, because I'm trying to drive revenues, and I'm trying to be better than the person next to two companies that are next to me that are building almost the same thing as I am. So what differentiates us?
Yep.
Technology.
Fantastic. Well, Mekki, really enjoyed this. I know that the data standard is going to enjoy the community. You've got a wealth of wisdom to share. And so if folks want to reach out, what's the best way for them to get a hold of you? Is that over LinkedIn, or how should they?
LinkedIn, or they can shoot me an email. I'm at Mekki, Mekki, at sbcglobal.net.
Fantastic. Thank you again for your generosity, spending the time with us. And we look forward to having you as a member of the community.
Thank you very much.